Welcome students for general principles and process of isolation of elements, part 2nd. In this video, we shall be studying about concentration of ore particles by using 4th floatation process, hydraulic washing, magnetic separation and leaching process. In previous video, students, already we have studied about ore and the minerals. So let's continue with the first process, that is concentration of the ore. Concentration of the ore can be carried by namely the 4 different methods which has been discussed with you. So the first method, that is 4 floatation, which can be used for sulfide ores, whereas hydraulic washing, students, this method can be employed for all the ores. Magnetic separation can be done for magnetic ores, whereas leaching process can be done for aluminium, silver and gold ores. So let's continue in detail about 4th floatation, that is for sulfide ores. Okay, the 4th floatation process, let us understand the principle involved in it. The surface of sulfide ores is preferentially wetted by oils, while that of the gangue is preferentially wetted by water. So students, the point to be remembered is surface of sulfide ores are only wetted by the oil what we are adding in this process, whereas the gangue particle that are impurities, they would be wetted by means of water. The diagram represents 4th floatation process. Let us consider method involved in the 4th floatation process. In this process, a suspension of the powdered ore, that is sulfide ores, is mixed with the water, and to this, students, collectors and 4th stabilizers are added, and a rotating pedal at the bottom of the container which is placed, which agitates the mixture and draws the air in it. As a result of this, 4th is formed at the top of the vessel, which carries the mineral particles along with it. Thus, 4th is light and can be easily skimmed off. It is then dried for the recovery of the ore particles. By this process, students, it is very clear that the gangue particles, that is impurities, are wetted by means of the water, and as they are denser, it would be settling at the bottom of the vessel. Whereas the ore particles, they are preferentially wetted by the oil. As a result, they would be present in the 4th which is formed, and by means of skimming off, it can be easily isolated. Now let us understand collectors and 4th stabilizers which we have used in the 4th floatation process. First one, collectors. The chemical substances which enhance the non-wettability of the mineral particles. For example, pine oils, fatty acids, xanthates. The main use of the collectors, students, it would be making the ore particles to repel the water molecules, and the ore particles would be wetted only by the collectors such as pine oil. Next, the four stabilizers. These are chemical substances which stabilize the fourth which is formed by the ore particles and collectors in the presence of air. For example, student, cresol and aniline. We are having different cresols. For example, paracresol, metacresol and orthocresol. It can be para-methyl phenol or else metamethyl phenol or orthomethyl phenol. Let us discuss about working using flotation cell. In this, students, a suspension of the finely powdered sulfide ore is mixed with water in the first step, and later we are adding collectors and fourth stabilizer. Already both the definition has been given to you. So the main role of the collectors, as you know, they would be preferentially wetting the ore particles, whereas fourth stabilizer, they are stabilizing the fourth which has been formed. So example for collectors, pine oil or else fatty acid, xanthate, and for fourth stabilizer it can be cresol, aniline, etc. In the second step, the mineral particles become wet by oil, while the gangue particles by means of water. A rotating pedal which agitates the mixture of ore, water, collector and the fourth stabilizer. So this mixture would be agitated by rotating pedal and draws air within it. As a result, fourth is formed which carries only the mineral particles. And finally, students, the fourth is lighter in weight and can be easily skimmed off. It is then dried for the recovery of ore particles. Now let us consider some of the diagrams which represents fourth flotation process. And in the first diagram, students, which you can observe here, fourth is getting formed which is collected in a receiver. As it is a lighter in weight, so all the impurities are settling at the bottom of this given container, whereas the fourth, which is preferentially wetted by means of the oil, it is collected at the top and falls down in a receiver which can be dried to get the respective ore particles. So this is done in a lab. Next diagram also represents the fourth flotation process done in a lab. And the third diagram, students, represents the industrial scale fourth flotation process. Now students, question arises, what if two sulfide ores are present? Then we need to add one more component which is called as depressants. Then now, what are depressants? Depressants makes it possible to separate two sulfide ores by adjusting the portion of oil to water. Then, what is the principle involved in this process of separation of both the sulfide ores? If we consider, student, both sulfide ores, that is ore number 1 and ore number 2, both are what? Sulfide ores. They are present in a mixture. Then we are adding depressant. So by the addition of the depressant, ore number 1 is in combination with depressant, which you can observe here. Ore number 1 in combination with the depressant, whereas ore number 2, okay, so which is completely separated. In this way, mixture of the sulfide ores can even be separated, students, by using depressants. Let us consider an example. In case of an ore containing both zinc sulfide and lead sulfide as the ores, effectively prevents zinc sulfide from coming to the fourth, but allows only lead sulfide to come with the fourth. Is the same you can observe within the diagram also. When lead sulfide and zinc sulfide are present in the ore, we are adding depressant as sodium cyanide. Sodium cyanide is reacting with zinc sulfide. As a result, student, we are getting a complex of it, whereas lead sulfide is free and it can react with the oil. Thus, formation of the fourth of only lead sulfide can be observed. Let us consider second method for the concentration of ore, that is hydraulic washing. In this process, students, the lighter impurities are easily removed away and the finely powdered ore, which is fed into this tank from the top position, and the water is allowed from the bottom of the tank with a high amount of the pressure. During this process, lighter impurities which are adhering towards the ore particles would be washed away by the current of the water, and the ore particles will settle down at the bottom of the tank because they are relatively heavier in nature when compared to that of the impurities, that is gangue particles. So let's proceed with the third method for the concentration of the ore, that is magnetic separation, and this method, students, would be applied for only magnetic ores. In this magnetic separation, let us first consider principle involved. Based on differences in magnetic properties of the ore components, the separation, that is magnetic separation, works out. This diagram represents magnetic separation, in which magnetic roller which is present, and both the rollers are interconnected by conveyor belt. At one end of the first roller, the addition of finely powdered magnetic ore which is added, whereas at the second end, students, you can observe the separation of non-magnetic particles and magnetic particles occur. So let us discuss here in detail. This process is used for the concentration of the iron ore, that is hematite ore. Why? Because iron exhibits magnetic behavior. Let us consider magnetic separation in detail, students. The finely powdered hematite ore, for example, which is passed through a belt which is called as a conveyor belt, which is connected by the two rotating wheels on its either side. One among is made up of magnetic material. Once the ore is passed through the belt, only the ore particles, students, are attracted by the magnetic wheel and fall exactly near to it, whereas the impurities that are non-magnetic particles which are not attracted by the same magnetic wheel and fall relatively away from the magnetic particles. which can be easily observed from this diagram. So you are having magnetic particles as a separate and non-magnetic particles, that is Ganch particles, as a separate heaps. And this diagram represents how the non-magnetic particles are easily getting separated. Whereas the next diagram, students, represents the commercial scale of the magnetic separation. Now let us consider working using magnetic separator. In this, students, we are adding finely powdered hematite ore right at the top on one of the magnetic roller. As a result of this, the ground ore is carried on a conveyor belt which passes over the electromagnetic wheel, and the electromagnetic wheel of the conveyor attracts only the magnetic particles into a separate heap, whereas the non-magnetic particles would be forming a different heap. In this way, student, the magnetic particles can be separated from the non-magnetic particles. Let us continue with the fourth method of concentration for ore, that is leaching method, which is done for aluminium, silver and gold metals. Leaching, students, is very oftenly used for the ore particles which are soluble in a suitable solvent. Let us consider principle involved in leaching process. Extraction of soluble material, that is ore particles, from an insoluble solid, that is Ganch particles, by dissolving it in a suitable solvent. So this is the principle of leaching process. A suitable solvent, students, which is used in the leaching process is called as leaching agent. In this diagram, students, you can observe the leaching process which is done to obtain soluble ore from the insoluble Ganch particles. Now let us consider principle of leaching along with a diagram. The ore particles which contains metal compound along with impurities. So the ore particles are treated with leaching agent. Leaching agent, that is suitable solvent, it would be dissolving only metal compound. As a result, we are getting a solution of the metal compound in that solvent, and along with this, student, the impurities which would be left as residue material. Impurities that are Ganch particles are not dissolving in that given solvent, that is leaching agent. In the next step, very easily we can separate the solution of metal compound with the solvent. As a result, you can get metal compound as a separate from that of leaching agent. Let us consider one example of the leaching. So leaching of alumina from bauxite ore. So this process is called as Bayer's process. In bauxite ore, students, aluminum oxide dihydrate is in combination with the impurities. So very easily we can remove these impurities when the bauxite ore is reacted with suitable solvent, that is leaching agent. In this case, we are using alkali, that is sodium hydroxide aqueous. This would be forming sodium meta-aluminate along with water molecule, and the sodium meta-aluminate is a water soluble component. As a result, impurities are not reacting with the sodium hydroxide, so impurities would be present as a solid residue at the bottom of the reaction vessel. In the next step, student, sodium meta-aluminate is reacted with plenty of water. Thus, we can get sodium hydroxide along with aluminium hydroxide as the product, and this aluminium hydroxide on heating, it would be giving us aluminium oxide along with water molecule. And in the next, we shall be considering Hall's process. In this, student, aluminium oxide along with the impurities, it is treated with a different reagent, that is sodium carbonate aqueous solution. So you are getting product as carbon dioxide, sodium meta-aluminate and water molecule. So as you know, sodium meta-aluminate is water soluble, so it would be dissolved in the water itself, whereas impurities, once again it is insoluble in the water. It would be settling as a residue at the bottom of the reaction mixture. Very easily we can separate that residue from the solution. And in the next step, sodium meta-aluminate reacts with carbon dioxide and water molecule for the formation of sodium carbonate. Along with that, aluminium hydroxide white color precipitate can be obtained. And this aluminium hydroxide, students, on heating, it is giving us aluminium oxide along with water molecule. So in this way we can use Bayer's process or else the Hall's process for isolation of aluminium oxide, and the all impurities, that is gangue particles, can be easily separated. So here in both the conditions, that is Hall's process, we are using sodium carbonate aqueous solution as a leaching agent, whereas in the Bayer's process we are using sodium hydroxide aqueous solution as a leaching agent. Next, students, we shall consider leaching of gold and silver. So first, leaching of gold. For this, we are using ores of gold which is reacted with sodium cyanide as a leaching agent in presence of water and atmospheric oxygen. So it is forming a complex which is soluble in nature, soluble in the water, and apart from it, hydroxyl anion. In this way, gold can be made to form a complex followed by soluble in the water, which can be easily be isolated from the rest of the gangue particles. Next one is leaching of silver. So silver ores are treated with leaching agent, once again sodium cyanide in presence of water along with oxygen, that is atmospheric oxygen. It forms silver complex which is water soluble along with hydroxyl anion. So once silver complex is water soluble, rest all the gangue particles are insoluble. They can be very easily separated from silver complex. Now students, in general, when metal M is reacting with sodium cyanide as a leaching agent in presence of water and atmospheric oxygen, it forms metallic cyanide complex which is soluble in the water. Along with this, 4 moles of hydroxyl anion, metallic complex which is soluble in nature. It is present in the solution state. So if we add zinc metal, then very easily zinc would be forming the complex by means of the displacement, whereas metal would be precipitated out. So here student, zinc is more reactive when compared with the metals such as gold or else silver. So easily zinc can bring about the displacement of gold or silver from their respective soluble complexes. As a result, zinc complex which is formed, which is water soluble, whereas metal would be precipitated at the bottom of the reaction vessel. So here zinc displacement reaction occurs. Thank you students. In the next video we shall be studying about extraction of metals from the concentrated ore. Thank you.